So here's another problem that's actually fairly similar to one of the homework problems. I think in the homework we do this with circles and spheres, but let's do this with a cube. So let's ask, how much does the surface area of a cube increase when the length of its side increases by an amount dx? Then let's use the answer to that to find how much the surface area increases if the side increases from 12 to 12.5 inches. And let's see how that compares with the real increase. Okay, so first thing you need to know is you're going to need to be able to write the surface area of a cube in terms of the length of its side. I'm hoping that I'm not hearing out there what's the formula for the surface area of a cube. I don't think that anyone's ever taught you the formula for the surface area of a cube. Rather, you just have to think about what you already know a cube looks like. It's a six-sided figure whose sides are all squares of size x by x. So it certainly makes sense to say not its volume, its surface area is equal to 6x squared. So the surface area of the cube is 6x squared, and that means that if we take the derivative, we can say that ds over dx, in other words, how much does the surface area change for every increase in the surface in the length of a side, is going to be 12x. So we can get from that ds is equal to 12x dx. So that's the answer. That's the answer to the first part of the question. In other words, how much does the surface area increase when the length of the side increases by dx? The answer is ds, which is the increase in surface area, is 12x dx. In order to know the actual value, note that we have to know two things. We'd have to know, first of all, what dx is. How much are we increasing the length of the side by? We also need to know what we started with. In other words, how much was 12x to begin with. So let's actually use that fact to answer the second part of the question, where we actually are given a starting value and an increase. So let's use the answer to find out how much the surface area increases, find out approximately how much the surface area increases if the side increases from 12 to 12.5 inches. Well, what we can see is that we're sort of starting with an x equal to 12. That's the sort of starting length of the side. And we've increased from 12 to 12.5 inches, which means we've increased by 0.5. That's what we're doing, is we're increasing from 12 to 12, so by 12.5, so we're increasing by 0.5. That means that ds is equal to 12 times 12. It's just sort of a coincidence the way I constructed this problem is these are both 12s. This 12 is kind of baked into to the formula for the derivative. The other 12 is just this number of inches I started with, and then finally that's going to be multiply that by 0.5. So this is x and this is dx. So that comes out to 12 times 12 is 144 times a half is 72. So the answer is 72 square inches. This is the approximate amount that the surface area of the cube increases when we increase the length of its side from 12 to 12.5. Now, let's see how this compares with the exact increase in surface area. I calculated it, and it turns out that 6 times 12.5 squared is equal to 937.5, and 6 times 12 squared is equal to 864. So in other words, so the first number is the actual surface area at a side of length 12.5. 864 is then the actual surface area when the side is 12. The difference between these is 937.5 minus 864 is equal to 73.5 square inches. So that's the actual amount that we increase the surface area by. And as you can see, the estimate is pretty close. It's not exactly right, but it's quite close. So this is just one way that you might use differentials. And sometimes it's just easier. It's just easier to use the tangent line approximation.